The binomial expansion of 1 plus kx to the power of n is given by 1 plus 12x plus 28k squared x squared plus dot 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 plus k to the power of n times x to the power of n, where n is a positive integer and k is a rational number. Find the value of n and the value of k. So from here, since we already can see that it is a binomial expansion, we can use the formula booklet to look at the binomial theorem and get a better understanding of how the expansion would work. So here we can already see that 1 would be categorized into A and kx would be categorized into B. And here we can start writing it 1 plus kx power of n and start expanding it in binomial. So we can already see that any integer exponent of 1 would always result in 1. So that's why the a power n, which is the highest amount of n here, would just still be 1, plus nc1 kx plus nc2 k squared x squared plus nc3 k cube x cube plus nc4 k4 x4 and so on and so forth. So from here, if you're wondering how I got k squared x squared, it's just another way to rewrite kx squared here. So it would become k squared x squared. So from here, we can already see that there is some kind of similarity with what we see in the top here. And that's because we have to compare our values here from the binomial expansion with the one that's given here. So nc1 kx is equal to 12x. And from here, nc1 is actually just another way to say n. And just to prove this, okay, we can try 3c1, all right? And when we are putting it in this form, it would be 3 factorial, 1 factorial over 3 minus 2 factorial. And when we're, 3 minus 1 factorial, sorry. And when we are actually going through with it, it would be 3 times 2 times 1 over 2 times 1. And then you just cancel this out and you would end up with 3. So yeah, you still get n. So anything nc1 would equal to n. Right. So another way to rewrite this is nkx is equals to 12x. And when we cancel the x's, it would be nk equals to 12. Next, we are going to compare nc2k squared x squared with 28k squared x squared. And here, let's do nc2k squared x squared is equal to 28k squared x squared. Now we can, of course, just cancel this out and we would be left with nc2 equals to 28. But to expand this in this form, we would be given n factorial over 2 factorial n minus 2 factorial. And when we are expanding this, it would be n times n minus 1 times n minus 2 factorial over 2 factorial n minus 2 factorial. Now you might be wondering, how did I get this? Well, an expansion of n factorial would just be n times n minus 1 times n minus 2, and this would just go on like forever, right? But since we are doing it only until n minus 2, we can put a factorial there, and then we can cancel this out, and we'd be left with n minus 1 over 2 is equals to 28. So from here, we know that n minus 1 is equal to 56 because we just moved 2 to the other side. And then we just expand it maybe it's just better to do it here. N squared minus n minus 56 is equals to 0. So I move that to the other side. And from here, we just try to find the factors of 56 that when summed, it would give us the middle value right here, minus n. I mean, minus 1. So it would be, yeah, it would be minus 8 and minus 8 and n minus 7 equals 0. N plus 7, I mean. So n would equal to 8, or n equals to minus 7, but this is not possible. So what we do with n here is just substitute it into this right here. So when to find k, we just do k equals 12 and just substitute n into here and move a to the other side. And just simplify or 8, well, okay, 3 over 2. And these are both our answers.